Dear students, welcome to the problem solving session on continuous random variable part 1. In the previous videos, we learned what is meant by discrete random variable, basic ideas, properties and problems. In today's session, we are going to learn about continuous random variable. A random variable x is said to be continuous. We have to check the range space Rx is always an uncountable set of real numbers. That is, the random variable should assume the values between the interval a comma b, or it should be in a union of intervals. Let us see some examples. If x denotes the lifetime of a transistor or lifetime of a mobile or any electronic gadgets, it cannot be discrete. It is continuous. It will work on a period of time. X denotes the operating time between two failures of a machine. So the sample space must be continuous. We cannot speak probability of the first value or probability of the second value or probability of any particular value in continuous random variable. Just have a quick recap. In discrete random variable, when you throw a die, we have possibilities 1, 2, 3, 4, 5 and 6, and then we can see their corresponding probability. Suppose if I am asking what is the probability of getting 3, you can say 1 by 6. But in the case of continuous random variable, I cannot tell the probability at any particular point. It is meaningless. We are going to see the reason in the forthcoming slides. In the discrete random variable, we were dealing with probability mass function. In continuous random variable, we mentioned this as probability density function. Here, we are going to take the function f of x, and it is defined at the interval minus infinity to infinity. The function f of x is said to be PDF. It has to satisfy the following conditions. First of all, my f of x should be always greater than or equal to 0. And the second point, it is very obvious. The total probability is always 1. In discrete random variable, we will tell like sum of probability is 1. Since it is continuous, we have a function. Therefore, we'll say integral minus infinity to infinity f of x dx is always 1. Therefore, a function is said to be probability density function. It have to satisfy these two conditions. Now, in problem solving point of view, we are going to see how to find p of x less than a, probability of x greater than a, or probability of x lies between some points a and b. We'll see one by one. If I say probability of x less than a, just we have a pictorial representation. So this is my curve and the point a. Probability of x less than a means my x lies between minus infinity to infinity. So my lower limit is going to be minus infinity and my upper limit is a, f of x dx. Next, obviously you would have guessed, if x greater than a, that means my lower limit start from a, it goes up to plus infinity, f of x dx. We can easily see that probability of x greater than a is integral a to infinity f of x dx. The pictorial representation is given here. Next, we are going to find probability of x lies between some value a to b. We can see the pictorial representation. Since a is less than b, integral a to b f of x dx is my answer for probability of x lies between a to b. Now, there comes a question. If suppose a and b are equal instead of a less than b, then what is the answer? If a and b are equal, then my upper limit and lower limit is going to be the same. Just recall from your school days, whatever the function f of x, it doesn't matter. If you have the upper and lower limit are going to be the same, then my answer is always 0. A and b are same, I don't get any area. So obviously integral a to a f of x dx is always 0. That is why I said in the beginning, finding probability at a particular point in continuous random variable is meaningless because it will become 0. The reason is my upper and lower limit are same. Whenever I integrate any function, and substituting the upper and lower limit, my answer is always 0. So I can find the probability for a given interval a comma b. I cannot find the probability for a given particular point. It is obviously 0. Hope you understand. From this, we are going to find the next content. What is probability of x less than or equal to a? When probability of x less than a, we will not include a. When I say probability of x less than or equal to a, we have to include the point a also. So I am going to rewrite this probability of x less than or equal to a as probability of x less than a and probability of x at the particular point a. Just now we see in continuous random variable, probability of a particular point is always 0. Therefore, we get probability of x less than or equal to a is always equal to probability of x less than a in continuous random variable. Therefore, in continuous random variable, p of x less than or equal to a is always equal to p of x less than a. In the similar way, probability of x greater than or equal to a, I can rewrite this as probability of x greater than a plus probability of x equal to a. And this is going to be 0 in continuous random variable. Therefore, we say probability of x greater than or equal to a is equal to probability of x greater than a. So in the similar way, if x lies between some value a and b, then all the combinations of this inequality, we are going to have the same answer. So we can easily see for all these 4 probabilities, my answer is integral a to b f of x dx. Hope you understand. Next, we are going to deal with CDF, cumulative distribution function. If x is a random variable, whether it is discrete or continuous, the formula for CDF is capital F of x is equal to probability of x less than or equal to small x. The formula for capital F of x is from minus infinity to x f of x dx. In all our formula, we have constant limit. Only for CDF, my lower limit is minus infinity and my upper limit is always x, because we are finding the function, we are not finding the value. You have to remember this. Next, very important, we are going to deal with properties of CDF. It is obvious, we know probability lies between 0 to 1, as well as capital F of x also lies between 0 to 1, and capital F of x is always an increasing function. So limit x tends to minus infinity, capital F of x is always 0 because my lower limit is 0, and limit x tends to plus infinity, capital F of x is always 1 because my upper limit is 1. Sometimes we can write this as f of minus infinity is 0 and f of plus infinity is 1. Next, we are going to deal with problems. Let us consider a random variable f of x. It is going to be 2x in the interval 0 to 1. So you should be very careful in dealing the problems. If the function or data is given in terms of interval, it is going to be continuous random variable. Suppose instead of this, if they are giving like x lies between 0, 1, 2, etc. up to 10, this is discrete random variable. But if they give the x values in interval, then it is going to be continuous random variable. So for a given random variable, we are going to find different probabilities, mean and variance. Let us do one by one. So probability of x less than 1 by 2. From the formula, integral minus infinity to infinity, f of x dx is always equal to 1. Now they are asking to find the probability of x less than 1 by 2. Less than 1 by 2 means up to 1 by 2, from minus infinity to 1 by 2 f of x dx. But our question says the function exists between 0 to 1 and 0 otherwise. So I can rewrite this as integral 0 to 1 by 2. In 0 to 1 by 2, my f of x is 2x into dx. Now I can integrate this. We get x square by 2 integral 0 to 1 by 2, that is 2 by 2 1 by 2 whole square minus 0. So my answer is 1 by 4. If the question is find the probability of x greater than 1 by 2, that means it is starting from 1 by 2. My lower limit is 1 by 2 and my upper limit is plus infinity f of x dx. Now carefully check your question. my x lies between 0 to 1. Therefore, we have to write like 1 by 2 to 1 f of x dx, and we have to proceed like this. The next question is x lies between 1 by 4 to 1 by 2. So my lower limit is 1 by 4, upper limit is 1 by 2, and my f of x is 2x because x lies between 0 to 1. The function is 2x. Integrating this and cancelling 2, substituting the upper and lower limit, we get 1 by 4 minus 1 by 16. So either use your calculator or do the simple calculation and find the solution. The answer is 3 by 16. Next, we are going to see a problem on conditional probability. Whenever you see conditional probability, just write the formula. Probability of A bar B or probability of A given B is equal to probability of A intersection B divided by probability of B. Here A is x greater than 3 by 4 and B is x greater than 1 by 2. Now we have to find the numerator probability of A intersection B, that is probability of x greater than 3 by 4 intersection x greater than 1 by 2. So if we can't write the answer exactly, always draw a real line. From this we can find the solution. Since my x value lies between 0 to 1, we are taking up to 0 to 1. A, we have x greater than 3 by 4. For B, we have x greater than 1 by 2. So I am splitting the real line as 0, 1 by 2, 3 by 4 and 1. First let us take B, x greater than 1 by 2. So from 1 by 2, it reach up to 1. But in the case of A, x greater than 3 by 4, so now it will take the value between 3 by 4 to 1. From this 2, I can see this region is common for both. Therefore, probability of A intersection B is simply probability of x greater than 3 by 4, the region which is common to both. So now we can easily found the value for numerator. Probability of x greater than 3 by 4. That means from 3 by 4 up to infinity, but our problem deals only 0 to 1. Therefore 3 by 4 to 1 f of x dx. My f of x is 2x. We can easily integrate this, cancelling this 2 and substituting the upper limit, that is 1 square minus lower limit 3 by 4 whole square. So 1 minus 9 by 16. So the answer is 7 by 16. And this is not the final solution. We just found the numerator. Now we have to find the denominator. Denominator is simply probability of x greater than 1 by 2. So it is very easy to find the answer. Integral 1 by 2 to 1 f of x is 2x dx. We can integrate and we can find the answer. Or since we found probability of x less than 1 by 2 in my first part of the problem, I can use complement. So probability of x greater than 1 by 2, I can rewrite this as 1 minus probability of x less than or equal to 1 by 2. Already we have found in the first part of the solution it is 1 by 4. I can substitute here and simplifying this we get the answer 3 by 4. Therefore probability of A bar B is probability of A intersection B divided by probability of B, that is 7 by 16 divided by 3 by 4. So 7 by 16 into 4 by 3. My final answer is 7 divided by 12. Next we are going to deal with mean and variance. The formula for mean in discrete random variable is summation x into probability of x. In continuous random variable, we have function f of x. Therefore, my e of x is going to be integral minus infinity to infinity x into the function f of x dx. And x lies between 0 to 1, where the function is 2x and remaining all the places it is 0. Therefore, I can rewrite this as integral 0 to 1 x into 2x dx. Integrating 2x square dx, we get x cube by 3. So 2 by 3, upper limit 1 cube and the lower limit is 0 cube. So the answer is simply 2 by 3. Next we are going to find variance. We know the formula of variance of x is e of x square minus e of x whole square. Just now we found e of x. We have to find e of x square now. And it is obvious e of x square is integral minus infinity to infinity x square into function f of x dx. Since our limit is 0 to 1, we can write this as 0 to 1 x square and the function is 2x. Now integrating this 2x cube, we get 2 into x power 4 by 4 integral 0 to 1. So 2 by 4, 1 minus 0. So it is 1 by 2. Now we found e of x square. Next, variance of x is e of x square minus e of x whole square. That is 1 by 2 minus 2 by 3 whole square. So 1 by 2 minus 4 by 9. So either use your calculator or just do manually find the final solution. So the answer is 1 by 18.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.